Next, we're going to learn about compound interest. So remember, simple interest was the interest calculated only on the principal. And it is only calculated once, and that's at the end of the time period. But compound interest is different. Compound interest is computed on the original principal as well as any compounded interest that you earn periodically. For example, let's assume that your bank calculated interest at the end of the year. If you deposited $1,000 in your bank account and accrue $50 of interest at the rate of 5% at the end of the year, then at the end of the year, you're going to have $1,050 in your account. Now, let's leave that interest in your account for another year. So then the interest after the second year will need to be calculated by 1,050 times 1 plus 1 times 0.05 equals, and when you type that into the calculator, it turns out to be $1,102.50. This is the compounding interest because during the second year, not only are you getting interest on the $1,000 that you put in, but you're also getting the interest on that extra $50 that you earned the first year. So that's compounding interest. You earn interest on the interest that you've already accrued. So a compounding period is a period between two compounding payments. We use the letter M to denote the number of interest payments each year. So here's some examples. Compounding annually means once a year. M is 1. Compounding semi-annually means every 6 months or 2 times a year, therefore M is 2. Compounding quarterly means every 3 months, which is 4 times a year, M is 4. Compounding monthly or 12 times a year, therefore M is 12. So those are just some of the words that come up an awful lot. There's obviously more like compounding daily. Next set of information we need to know. A is going to be represented as future value. Capital P is going to represent present value or the principal, so however much you have right now. R, like before, is the annual interest rate. T is the time in years, just like we used in simple interest. M is the number of compounding periods in 1 year. Now N is going to be the total number of compounding periods over the life of the loan. The way we're going to get that is you're going to take M, which is the number per year, times T, which is the number of years, and that gets you the total number of compounding periods over the whole life of the loan. So this one has a little formula. Because there's so many letters here and we're going to be plugging this in a formula, it's going to be easier to do some of the small computations like N equals M times T before you type it into the calculator. And then the last one is the I, interest rate per period. The interest rate for the year is R, but if you take that interest rate for the year and divide it by however many months are in a year, you get the interest rate per period. So if you have an interest rate of 5% over the whole year, that would mean R is equal to 5%, okay? But you're compounding monthly. To get the I, this is just an example, okay? To get the I would be 0.05 divided by 12, which is 0.00416 repeating. So for every month, you're only getting if you move the decimal over here, a 0.4% interest that month only. But over the whole year, you're going to get more because you're compounding every month than you would if it was just 5% over the whole year. So compounding more frequently is going to get you a better return on your money. So next we're going to go through the formulas. If you deposit P dollars at a rate of R, in decimal form, subject to compound interest paid m times a year, then the amount of A, which is our future value, of money at the end of the account after t years is given by this formula. A equals P, parentheses 1 plus I to the n. Notice that's kind of similar to our simple interest formula. I has been replaced and the n exponent has been added, but it wasn't before because we were doing it compoundingly. Now if I manipulate this first equation and I divide both sides by the parentheses right here, then I will get this other formula. So these two formulas are basically the same formula. Why would we need two of them? Well, because we have one solved for A and we have one solved for P. Okay? So sometimes you're going to want to know your future value to know how much money you're going to have in the future. And sometimes you want to know how much you need to deposit now so that your account is going to have something specific in the future. So these two formulas are the same formula, but just solved for the different values. Now don't forget that we have our sub-formulas in here, and when you're trying to find I is equal to the rate divided by m. And when you're trying to find n, that's m times t. Those formulas, if you do them before you plug them in to the big formula, it's going to save you a little bit of time and a bunch of parentheses when you're trying to type it in. So the first formula is used when you're solving for future value. Or when you need to know how much money you're going to have in the future. So let's say I deposit P amount of dollars. How much is it going to be in 5 years? That's what I want to know. Okay, so that's this one right here. All right, but the second formula is when you are solving for present value. And we will use that if you need to know how much to deposit now so that your account will have a specific amount in the future. So let's say you're trying to save up for a down payment on a car. You need $5,000 and you know you have 2 years to get that. How much do you need to deposit now so that the bank will pay you enough interest so that you can have your $5,000 in 2 years? So that would be a situation where you might need it in the future. Let's go ahead and try one of these problems. So I've rewritten some of the formulas up here so it's a little bit easier. You don't have to keep flipping back. Our first example, a sum of $10,000 is invested at an annual rate of 8%. Find the balance at the end of the account after 5 years subject to compounding quarterly. So it says a sum of $10,000 is invested. So is that an A or a P? Well, that's a P. That's how much we're putting in right now. So then let's list all of the values we might need. R, M, T, N, and I. Okay, so I know I have $10,000 is invested at an annual rate of 8%. So rate, that's R, so that's 0.08. Find the balance after 5 years. So that's T is 5 years. Subject to, for part A, we're compounding quarterly. Quarterly is 4 times a year, so M is 4. Now, I don't have A, N, or I. Now, remember N and I have formulas that go with them, right? So I is equal to R over M. So when I'm trying to do that problem, I'm going to use R divided by M. I know R is 0.08. Divided by m, which is 4, and that gets me 0.02. So that helps me out quite a bit when I'm trying to plug it in the formula. N is equal to mt, so when I try to find n, I'm going to take my values for m and t and multiply them. M is 4 times a year times 5 years, so that's going to be 20 total compounds. And now I have everything except A. So because I have everything except A, I'm going to use the A formula. A is equal to P parentheses 1 plus I to the N. So I have A equals 10,000 times the parentheses 1 plus the I, which is 0.02, to the N, which is 20. Now I need to get out a calculator. So I'm going to type in 10,000, then the parentheses, 1 plus 0.02, close that parentheses, use my caret button, 20. And that gets me A is equal to $14,859.47. So I deposit $10,000, and 5 years later, with this set of circumstances, I'm going to get $14,000, 859. Okay. All right, let's try this again. Part B, the only difference in Part B is that we are compounding monthly. Now we said if you're compounding more frequently, do you think you're going to get more money or less money? Take a little guess there and we'll figure this out. Notice my P stays the same, $10,000. My rate is still 0.08, but my M is the only thing that is changing for Part B. I'm now compounding monthly, so M is 12. When I try to find I, I'm using that blue highlighted formula, which is R divided by M. My rate is 0.08 divided by 12. Now 8.08 divided by 12 doesn't really come out nicely, so I'm just going to go ahead and plug that in. 0.08 divided by 12, because 0.006 repeating isn't easy for me to type in the calculator. For the pink formula here, N equals M times T. My M is 12 times my T, which is 5. So this one's going to have 60 compounding periods over the life of the loan. I'm still using my first formula. So I'll plug in my new values. P, which is 10,000 times 1 plus I. Now I didn't come out really nicely, so I'm just going to go 0.08 over 12 raised to the 60. And I'll show you how to type that in the calculator. 10,000 times parentheses 1 plus, and we're just going to type 0.08 divided by 12 and close your parentheses. Raised to the 60. And this comes out to be $14,898.46. We'll round that up. When you're in MyMathLab doing the homework, make sure you're paying attention whether you can round it up or round it down. Okay, so comparing the two parts, when you compound quarterly or only 4 times a year, you're getting $14,859. When you're compounding monthly, which is 12 times a year, you're getting $14,898. So it looks like if you compound more frequently, you're going to get more return on your money.